Assalamualaikum and hi everyone. Today we are going to learn the subtopic on balancing redox reaction in acidic medium. Okay, now we move on to the step in balancing redox reaction. The first step is separate the reaction into two half reaction, which means that separate the reaction into oxidation reaction and reduction reaction. And then after that, for step number 2, determine the oxidation number for that species. Okay. Next, in a separate half fraction, step number 3 is balance the atom and charge in each half fraction. Okay, so in this step is the crucial part, which means in half fraction oxidation, we must balance the atom and charge after finish, and then we go for the reduction reaction to balance atom and charge. Okay, we must do one by one. Okay, under this step, atom must be balanced other than hydrogen and oxygen, and then next balance the atom oxygen by adding H2O or water, and then next is balance the atom hydrogen by adding H plus, and then balancing the positive charge by adding the electron.
Next, multiply each half of fraction by an integers to equalize the electron. Step number 5, combine two half fractions together and cancelling substances that appear both sides. After that, check atoms and charge balance.
Okay. Just now, we learned about the step on balancing redox reaction in acidic medium. So we go for the example, how to balance redox reaction. Okay, the equation is permanganate ion plus ferrous ion producing manganese ion and ferric ion. Okay, so how to balance this redox reaction? Just now, we learned about the step on balancing redox reaction. Remember step number 1? Step number 1 is separate the reaction into two half reaction and find the oxidation number for the species. We have the equation before, right? So, we choose the first reaction is permanganate ion MnO4 minus producing manganese ion manganese Mn2 plus, and then find the oxidation number for manganese. So we have to find the oxidation number for manganese for the reactant and the product. So how to find the oxidation number for manganese in permanganate ion? Okay. Since the permanganate ion is polyatomic anion and we have charge negative 1 here, so the charge for total polyatomic anion is negative 1. And we know already the oxygen is negative 2 for the oxidation number. So we can find the oxidation number for manganese. And then oxidation number for manganese is plus 7. Alright. And then for manganese ion, so we can look at the charge here. So the oxidation number is plus 2. So the oxidation number for manganese from plus 7 to plus 2 is reduced or decreased. So the half fraction here is reduction. Now we go for the second half fraction is involving ferrous ion Fe2 plus producing ferric ion Fe3 plus. So find the oxidation number for iron. So we can look here, the oxidation number for iron is plus 2 and the product is plus 3. So for the oxidation number for iron, we can look at from 2 increase to 3. So the half fraction here is oxidation. Next, step number 3 is balance the atom and charge in each half fraction. Okay, so in separate reduction and oxidation, we must do one by one, balancing the atom first, others then oxygen and hydrogen. So for reduction part, okay, from permanganate ion MnO4 minus to Mn2 plus. Okay, so balance the atom manganese or Mn. So we look at the uh, manganese atom for left side. Okay, so left side has one atom manganese only. Then for right side is also one atom of manganese. Okay, so how we want to determine how uh, much the atom. So we look at the stoichiometric amount and the subscripts. So there are one atom manganese left side and right side. So the atom manganese has balance already. For oxidation part, okay, from Fe2 plus ferrous ion to Fe3 plus ferric ion. So look at the atom of iron. Okay, so there are one atom on left side and also there are one atom on right side. So atom iron already balanced for left and right side. Okay, there are one atom for both sides. Okay, if other example which is not balanced, so you must added amount on stoichiometry here to make the amount of atoms uh, similar for left and right side. Okay, next, after balancing the atom other than oxygen and hydrogen, next is balance the atom oxygen by adding H2O. Okay, so for reduction reaction, okay, from permanganate ion forming Mn2 plus. Okay, so now we look at the total number of oxygen. Okay, for left side is 4 atom oxygen. Okay, for right side, is there any atom oxygen? No, right? So how to solve it? Okay, so to balance atom oxygen, we must adding H2O. Since left side has 4 atom oxygen, to balance it, for the right side, you must add 4 H2O. Okay, so now we look at the total number of oxygen for left and right side. For left side is 4 atom oxygen. For right side is also 4 atom oxygen. From here, 4 times oxygen is 4 atom. Okay, so now left side and right side is 4 atom oxygen and the atom oxygen has balance already, right? For the oxidation part, okay, since we have balance already for atom iron, and there's no oxygen atom for left or right side, so there's just skip the step, okay, because there's no oxygen. So we go for the next step. Okay, now we must balance the atom hydrogen by adding H plus. Okay, in a reduction reaction, so the permanganate ion forming manganese ion with 4H2O. So here you must find how many number the atom of hydrogen. Okay, so for left side there's no atom hydrogen. Okay, for right side here, since we added 4 mole of H2O, right? So find the total number of hydrogen. Okay, so for now the hydrogen is 4 times 2. Okay, so the total number of atom hydrogen is 8 for the right side. Okay, but for the left side there's no atom hydrogen, right? So look at the step to balance atom hydrogen, adding H plus. So since right side has 8 atom hydrogen, left side you must add 8 H plus, okay, to balance the atom of hydrogen. Now you look at the atom hydrogen, right side 8 atom hydrogen, left side also 8 atom hydrogen. So now both sides has 8 hydrogen, so the atom hydrogen is balanced already. For the oxidation part, okay, from Fe2 plus forming Fe3 plus, so there's no atom hydrogen, right? So there's no atom hydrogen to be balanced, and we can go for the next step. The next step is balance the charge by adding electron. So you must calculate the charge for left and right side, and then adding electron to balance both sides. For reduction, okay, the equation is MnO4 minus plus 8H plus forming Mn2 plus and 4H2O. So we must calculate the charge in left and right side. Okay, so for left side, let's calculate together the charge. So MnO4 minus means the charge here is minus 1, and 8H plus, so 8 times plus 1 means that plus 8. Okay, so the charge for left side is plus 7. Okay, plus 7. And then for the right side, is Mn2 plus, so 2 plus is the charge for the element manganese, and here you look 4H2O. Okay, no charge for 4 mole of H2O, so here is a 0 charge. Okay, so for the right side, 2 plus 0, so equal plus 2. Okay, so now left side is plus 7, right side is plus 2. So how to balance the charge? We must adding electron to balance it. Okay, so since left side is plus 7 and right side is plus 2. So we must adding electron in the left side, 5 electron. Okay, so it's like electronegative charge. So 7 adding electron in negative charge. So equal for the charge plus 2 for both sides. Okay. So next, for oxidation, okay, so we look at the Fe2 plus and Fe3 plus. Okay, so how to check the charge? So Fe2 plus is plus 2 for left side, Fe3 plus is plus 3. Okay, so for the oxidation, the addition of electron is at the right side. So since 3 charge for right side, so adding electron, 1 electron only to balance the charge. So both side now is plus 2. Okay, so for the oxidation, adding the electron on the right side or the product side, okay, releasing the electron, and for the reduction, adding the electron at the reactant part or gain the electron, right? So now the both half fraction has balance already for the charge. So the reduction has both plus 2. For the oxidation, both side is plus 2. Next, step number 4 is multiply each half fraction by an integer. Okay. So if the numbers of electrons in both half fraction is different, so the electron must be equalized to combine the both half fraction. In reduction, for example, so we look here, MnO4 minus plus 8H plus 5 electron producing Mn2 plus 4H2O. So here is 5 electron in reduction part. Okay, 5 electron is gain in reduction. Next is in oxidation reaction. So Fe2 plus forming Fe3 plus 1 electron. So to equalize the electron here, the oxidation has 1 electron, but for the reduction is 5. So to equalize the electron, all the oxidation reaction must multiply with 5. So now the reaction is 5 iron 2 plus producing 5 iron 3 plus 5 electron. So the reaction in oxidation now is release 5 electron. So both half reaction has same number of electron. Okay. If other example has already similar the number of electron, just go for the next step. Next, step number 5 is combine the half fraction together and cancelling the substances that appear both sides. So we write again the total reduction fraction. MnO4 minus plus 8H plus 5 electron producing Mn2 plus 4H2O. Next, for the oxidation, the half fraction is 5 iron 2 plus, forming 5 iron 3 plus 5 electron. Okay. Since the electron for reduction and oxidation is 5 electron and similar, we can combine the overall reaction. So now write the overall reaction. Okay, so write the reactant part first. Okay, the overall reaction now is MnO4 minus plus 8H plus 5 electron plus 5 iron 2 plus. Okay. Producing for the product, okay, take the product for both half fraction. Mn2 plus 4H2O plus 5 iron 3 plus 5 electron. Okay, so now we look at the number of electron. There are 5 electrons for left and right side, and can cancel the substance of electron. Okay, 5 minus 5, now there's no more of electron. So the total or the overall reaction is MnO4 minus plus 8H plus 5 iron 2 plus, producing Mn2 plus 4H2O plus 5 Fe3 plus. Next is step number 6. Step number 6, check atom and charge the balance. Okay, so for the overall reaction, MnO4 minus 1 plus 8H plus 5 iron, producing Mn2 plus 4H2O plus 5 iron 3 plus. Okay, so let's check the atom for left and right side. For left side, okay, we look for the manganese first. For the Mn, so 1 atom Mn left side, right side 1 atom Mn for manganese. Okay, for oxygen, okay, so for the subscript here is 4, so the stoichiometry amount here is 1 times 4, so 4 atom oxygen for left side. For right side, oxygen in H2O, okay, so 4 atom oxygen. So 4 atom oxygen for left and right side, balance already. Next, for hydrogen. Hydrogen is here 8 left side, right side. The stoichiometry times the subscript 4 times 2 is 8 for hydrogen. So 8 hydrogen left and right side. And then for iron, look at here is 5 atom iron for left side. Right side also 5 atoms iron. Next, check for the charge. Okay, so for the MnO4 permanganate ion is -1. 8 times plus 1 is 8. Okay, then 5 times 2 is 10. Okay, for the iron. So -1 plus 8 plus 5 times 2, 10. Okay, so total is -1 plus 8 plus 10 is equal to 17 for left side for the charge. For the right side, Mn2 plus, so 2. Okay. For H2O here is neutral, so 0 charge. For iron here, 5 times 3 is 15. So 2 plus 0 plus 15 is 17. So balance already right. Alright. So the equation now, after we do the step one by one, okay, and then now balance for all atoms and charge.
That's all for subtopic balancing redox reaction in acidic medium. I hope all of you understand with this topic. Thank you.